So this is the graph of the function log base 2 of x, okay? And they've graphed it. And then it says the function g is defined as 2 times f of x minus 4 plus 3. So we're just going to graph this function in a second. But what you need to understand is that this minus 4, that's going to shift it 4 units to the right. And then this 3 is going to shift it up 3 units, okay? So what does that mean? It says, what's the domain of G? So right now, if I look at F, right? If I look at F right now, I have a domain of 0 to infinity. Now, that's because you guys, there is a vertical asymptote at 0. It is never going to cross 0. In other words, x can never equal 0. That's the very nature of a logarithmic function, okay? Now, unless we shift it left or right. So now when I shift this over 1, 2, 3, 4, I'm going to get a graph that kind of looks like this, but it's also going to be shifted up 3 units. So it's going to look sort of like this, okay? And actually it's going to be much higher than that. It's going to go, because you're multiplying it by 2, so it's going to go pretty high, right? You're going to shift it up 3. In other words, if it's equal to 5 here, it's going to be equal to 10 up here plus shift it up 3. So it'll actually go off this screen. So it'll look something like this, but it's never, we're still going to look at the domain, right? The domain is going to be from 4 to infinity. So this would be x is going to go, this is the domain of x, the all possible values of x, such that x exists from 4 to positive infinity. So this is the domain. Okay? And that's a fancy math way to write it. And basically what I'm saying is the domain, all the possible x values, at where such that x is 4 is less than x and less than positive infinity. Okay? And I'm not even going to graph it. I don't need to.